So Algebra 1B, okay? You guys will be able to identify polynomials and their degrees. Section 6.4. Wait. Polynomials. That sounds like a big word, okay? That sounds like something a parrot would say. Get it? Polylonic? Okay. All right. So, polynomial. Poly just means many. Okay? It literally just means the word many. P-O-L-Y, many. All right. So, we're going to have this thing called a polynomial. And it's a number, a variable, or a product of a number and one or more variables. Okay? So it's a number, a variable, or a product of a number and one or more variables. Excuse me. I said polynomial. I need to change that, guys. I'm sorry. I know. Monomial. I'm sorry, guys. This might be. Monomial. Now, what does mono mean?
A disease.
Okay, disease. Okay. M-O-N-O. It's an abbreviation. Doesn't mean many. It means one.
Yeah.
It means one. Okay? It means one. Okay? Has anyone ever heard the word mono in something before besides maybe like a disease?
Yeah.
Okay? Tobin, where somewhere you've heard it?
Science.
Okay? Where at in science? You know?
Miss Poppins, yeah.
Okay, like what about?
Biology.
Okay, biology? Okay. Like with chromosomes?
Yeah.
Okay? And mono, it had like one set versus like a di, which had two.
Yeah.
Okay? Because the prefix mono means one, okay? Or maybe sometimes in different religions, okay? You have monotheism and polytheism. Monotheism means that there's a belief in one God in the religion, where polytheism means there's a belief in multiple gods in the religion, okay? So the religions are often separated into those kinds of theisms, mono or poly, okay? One or many. So monomial is a number, a variable, or a product of a number and one or more variables. Notice the a, okay, it's not like multiple, it's just one number, one variable, or a product, one grouping of it. Monomials do not include denominators of a variable. What? I think you're the same place I was. You need to go back a page. There you go.
What the heck?
Yeah, you were in the same spot I was when I was messing up. All right, they do not include denominators of a variable. They do not include addition or subtraction. Monomials that are real numbers are called constants. So if it's just a number, they're called a constant.
A lot of writing today.
Yeah, it's some vocab. It's easily vocab every day. Here are some examples of a monomial. Okay, you could have 3. 3 is a number. Technically, it's called a constant. Okay, because it's constantly 3. So 3 is a number. Okay, I could have the variable x. Okay, it's a variable. I could have the product x squared y. That's a product of variables. It's one grouping of variables. I could have 1/2 a, b, c. Okay, that'd be okay for me to have. Now notice it said no denominators, but I have a denominator there. But it says no denominators of a variable, like no variables in the denominator. Do I have a variable in the denominator? No, it's a number, it's 2, okay? So some non-examples. What does non-example mean? Does anyone know?
Non-example.
Yes, what does it mean?
Like, it's
No
not
example?
what you're...
It's not what you're looking for, right? It's an example of what not to do, okay? That kind of thing. Is that what you're going to say, Maddie? Love it, yeah. No, okay, never mind. Okay? It's an example of what not to do, okay? So non-examples here, okay, would be like A plus B. Why would that be a non-example?
Because it's addition.
There's addition. It specifically says do not include addition, okay? Would it be the same thing if I did like x minus y?
Yes.
Okay, yeah, same thing, okay? Now what if I just did like 1 over x squared?
No.
Why not?
Because it's a variable in the denominator.
Very good. Variable in the denominator. Okay, those are the two things that kind of, or the three things, so to speak, that break it up. Addition, subtraction, one or two things, depending on how you want to classify that. And then a variable in the denominator that make it not a monomial. It's no longer one thing. Now, if I took this a plus b, and I covered up that plus b, is the a monomial?
Yes.
Yeah. If I covered up the a plus, is the b a monomial? Yeah, but when I put them together, is that? No, it's not. It's a plus b. So on number 1, 8f squared g, is that a monomial?
Yeah.
I agree. Is there anything that makes it not a monomial is really the question we have to ask. Is there any addition or subtraction, or is there a variable in the denominator? Okay. I'll put it away, Olivia. Thank you. Okay. On number 2, what are we thinking?
No.
No. Okay. Now why not?
This is subtraction.
Okay, subtraction. Okay, no, because there's subtraction. So let's even go and write that reason in there. That way, if we come back to these notes, we can remember why we said no. Okay. Or circle the minus sign. Do something that'll help you know why it didn't work. Now, if I remember correctly, on your number 3, it just kind of came out as a jumble. Is that correct? Okay, there's nothing there even, okay? So go and write in 3 over 4. Okay, I want you guys to do number 3 and number 4, okay? So we're going to do number 3 and number 4, and raise your hand when you have it or have questions. Okay? On number 3, 3 over 4, is this a monomial?
Yes.
Yeah, there's nothing that makes it not a monomial, okay? There's no addition or subtraction, and there's no variable in the denominator. Now, what about number 4?
It's not.
No, why not?
Because that number's on the top.
Okay,
Variables
but it's more so because there's a variable in the denominator. It's not that there's a number on the top, but it's that because where the variable is. The variable's in the bottom. So no, you could say a variable in the denominator. Give you some sort of reason. So when you go back and look at this again, you can remember, okay? Look, yeah.
Okay, so what if you have like t over 5? Is that fine?
Great question. So what if we were to have t over 5? What do we think? I think so, okay? It doesn't break any of our rules, okay? It has addition or subtraction. No, it doesn't have any of those, okay? Variable in the denominator. Nope. Variables in the numerator. So t over 5, that'd be grand. That would be a monomial. Yep, great question. Love that. Any other questions on this? All right, now let's move on to the section I was trying to fill in earlier, okay? So this is a polynomial. So a polynomial, poly just means many, okay? So this is like going to be like many monomials, okay? So a polynomial is either a monomial or a sum of monomials. What does sum mean? Addition, okay? So meaning we're going to take monomials and we're going to put many of them together, okay? Or sometimes just one. So like monomial is like a subcategory or a part of the polynomials, okay? So we have special kinds. Notice how these are kind of like sub-bullets. You guys know how that works, right? Okay, this is like the main bullet, and these two clear bullets are like sub-bullets. Like they go underneath this point. They deal with the point, okay? So a binomial, what does the prefix bi mean? 2, like bicycle, okay? It's a sum of or difference of 2 monomials. Does that make sense that a binomial would do with 2? Okay. And what do we think is going to be the sum or difference of 3? Trinomial. Just like tricycle. Okay, we're going to have that prefix tri. And then if you have more than 3 terms, we just don't have a special name. We call it like a 4-term polynomial or a 5-term polynomial. You just keep calling them however many numbers you have. But we stop with the special names. So here are some examples of some monomials, binomials, and trinomials. Now, all of these are considered to be polynomials. They're all considered to be polynomials, but more specifically, these are monomials, binomials, and trinomials. So notice in the monomial, we have 7x, or like 4xy to the third z squared. Is there any addition or subtraction? No. No variables in the denominator either, okay? The binomial, though, if we separate the 3 plus 4a, 3 is a monomial, 4a is a monomial. We add them, that's 2 monomials, 2 binomial. Same with 7cde plus cd squared. They're 2 different terms, 2 different monomials, so that makes it a binomial. On the last one with a trinomial, we can do a subtraction as well. A plus b minus c, that's a trinomial. They're separated by the addition subtraction. 3x squared minus 2y plus xy squared. This is also a trinomial. They're separated into 3 different parts. So what kind of separates out our terms here, or our monomials here? Okay, Mason?
Actually, I don't know.
Okay. What do we notice is kind of separating each part of this?
Oh, there's different like I don't know what the word is.
The signs?
Yeah.
Okay, the addition and subtraction?
Yeah.
Yeah, the addition and subtraction signs are separating things out for us, okay? So these are all polynomials, but more specifically, trinomials, binomials, and just the monomial over there. State whether each expression is a polynomial, first of all. So once again, it can't break that rule of the variable in the denominator, okay? If it does break that rule, it's not even a polynomial. But then, if it is a polynomial, identify it as a monomial, binomial, or trinomial.
Wait, so none of them are? Because you said no addition.
Great question, great question. So the no addition or subtraction thing, that dealt with monomial.
Okay.
So for it to be a polynomial, we say, oh, it can have the addition and subtraction, but each individual one is a monomial. Together, it's a binomial, which is a different type of many nomial.
Okay.
So it starts kind of getting like onto categories here. Okay, Mason.
Wait, so a binomial is only 2?
Yep.
Like 2.
2 different parts. So we have the 3, we have the 4a, or we have the 7cde, and we have the cd squared. Yep. So by 2, try 3, mono 1. 3a minus 7bc. So in order to say if it's a polynomial, first of all, we have to say, is 3a a monomial? Okay. Is 7bc a monomial? Okay, so this is a polynomial. If each individual part is a monomial, then it is a polynomial. So we can first say yes, because it says state whether it is a polynomial. So our answer to that is yes, it is. Now, what kind is it? Is this a monomial, binomial, or trinomial? It's a binomial, right? Because there's 2 different parts. And we call each of these parts, okay? Each of these parts, they're monomials. We also will sometimes call them terms. Have you heard us talk about combined like terms? Okay, that's where that comes from. Is because these are terms. 3a is a term. 7bc is a term. And terms are separated by the plus and minus signs. Okay? Now on 2. Is there any individual thing, as we cover them up, that is not a monomial? No, okay? So it is a polynomial. So our answer to the yes or no question at first is, yes, it is a polynomial. Now, we ask ourselves, is this a monomial, binomial, or trinomial? But we might say, does this fit into any of the categories? No, but wait. Is there anything that we can combine here?
Yeah.
The 7a and a, those are like terms, right? What are those combined to be? 8a. So this really is 3x squared plus 8a minus 2. So Tobin is right when he says that, yeah, it's a trinomial. Did it look like a trinomial at first? No. So notice this instruction here where it says be sure to simplify first if possible. You have to be careful there, right?
Yep.
Alrighty. Let's look at number 3. If we look at each individual part, are both of those monomials?
No.
No, why not?
There's a denominator.
Nope, there's a variable in the denominator, okay? So, it is not even a polynomial, so it's not a polynomial. Feeling it. Little umbrella. All right. Any questions on that one of why that one's not a polynomial, but the other ones were, that kind of stuff? At this dance? Oh, no, I'm trash. Yeah. Yeah, I mean, I appreciate the compliment there, but it is not true at all.
I Remember when you could use like the Xbox 360, you had to do like the connect thing?
Yeah.
Do it?
Yeah. Yeah.
You have so much room to do it.
Mm-hmm. Mm-hmm. Oh man, the days. Yo, so
What are you saying?
I'm joking.
okay, so I was talking to my friend the other day, and they were talking about how these people who have jobs and they go underground and they dig up like coal and stuff like that, and like they wear all these hard hats and have like a lot of flashlights, and I'm like, why are you giving me all these minor details?
Ha 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 ha. So funny.
I don't get it.
I don't know
That's a
mine
knee
is.
slapper. Minor. Yeah.
Okay. Yeah, minor, like they're insignificant, but minor because it's about minors. All right. Anyway,
You should do a joke with it.
you're confused as to what the joke was?
Yeah.
So I'm describing details about people that are minors, correct? Okay. But when you say, what about all the minor details? You're going to on and on about the minor details. You're saying the smaller details.
The minor.
So it's a play on word about minor and minor.
When someone doesn't get my joke, I'm like, whatever.
That sounds like you. All right. What is a degree? Now we're not talking about a temperature degree where you turn up the degree and the dad instantly knows you changed the thermostat. Okay. We're not talking that. We're talking the degree of a monomial and the degree of a polynomial. Okay. So this is going to deal with the powers, the exponents. Okay. So the degree of the monomial is the sum of exponents of all its variables. The sum of the exponents of all its variables. Sum is what operation again? Addition. So we're going to add up all of the variables, the exponents on the variables.
So 1 is 3.
Yep. So the degree of a polynomial, though, actually we'll get to that in a moment.
Oh, okay.
We'll get to the second part in a moment. Let's go down to these examples and then we'll come back up and fill in that blank. So find the degree of each monomial. So it says exponents of all its variables. So do we care that the 8 secretly has an exponent of 1? No, because it says the exponents of all its variables. Is 8 a variable? No. Y is a variable. So what's the sum of all the exponents here? Just the 3. So the degree of the polynomial is 3. What about on number 2? What would the sum of all the exponents on the variables be?
4. Wait.
8.
2.
Oh.
1 plus 1 plus 2, 4. So, there's secretly a 1 on the 4, but we don't care about that right now because we only want the sum of exponents of the variables. So the variables are a, b, and y. The exponents are 1, 1, and 2. We have to add all of them, even the invisible ones we don't see. What about on 3? 0. There's literally none.
Wait, no, then
Awesome.
how would that be? Oh, never mind.
Okay, so we're not saying 14 has an exponent of 0. We're just saying there's no variables with exponents, so it has a degree of 0. It's a 0 degree monomial. What about on number 4? 3. Does it matter that there's a squared there? No, not even slightly, because it's not on a variable.
Almost added it.
Okay, almost right, but you gotta catch yourself. Okay, so then we ask ourselves, well, what happens when you're on a polynomial? Okay, so the degree of a polynomial, it's the largest or biggest, whichever one you want to use, degree of any term in the polynomial. So you take each term or each monomial, because we said we can call them terms as well, and say, what's the degree of this? What's the degree of this? Okay, which one's bigger? Because we're just going to go with the bigger one. Okay, so you have to find the degree of each term to compare. So on number 1 down here, what's the degree of 9x squared? 2. What's the degree of 2x? 1. So which one's bigger? 2. So the degree is 2.
So we don't put 9x squared.
Correct. So this is just asking for the degree.
Awesome.
This is just asking the degree. So the degree of this polynomial is only determined by the biggest degree.
This is easy stuff.
Good.
No, I think it's
Okay.
pretty hard.
On 2, what's the degree of this first term?
3.
Okay, what's the degree of the second term? Next? Next? Which one of those is the biggest?
3.
3. So what's the degree of the polynomial?
3.
3. So, recapping real quick before we go on to the next one, guys. When there's no addition and subtraction, you just add all the exponents of the variables. When there is addition and subtraction, you say, okay, well, let's look at each individually and say, okay, what's my biggest? Okay, we're not adding 3, 2, and 1, though. On 3, what do we think our highest power is? Raise your hand
4.
if you want to tell me what you think our highest power is. Tucker.
4.
I agree, it's 4. Okay, this has 1, this has 4, this has 2. 4 is the biggest power. Questions on that?
You wrote that really well.
I did. I wanted to make it to avoid the watermark.
The watermark.
Wait, there's a watermark?
That's what that's called. That's like overlaid.
Oh, yeah.
It's called a watermark. So like when you see like a company like have their like little logo on the bottom right hand corner or some corner of it, it's called a watermark. Yeah, it's like saying, hey, this is ours. We want to make sure everyone knows we made it because this is usually a free product or it's a restricted product where it's like copyrighted or something. So, any questions on any of that, guys? The degree stuff?
No.
Okay.
Can I take this house right now?
Jot. All right. Our last 2 examples for the day.
Yay.
Like, no cap.
Is there homework big?
Last 2 examples in the last 3.
See me. Last 3 examples of the day. Sorry, maybe there was some cap then. And I am a... Okay. Anyway, hey Bryce. Rewrite each polynomial in standard form. Wait, do we know what standard form means yet?
No.
Okay, we need to learn that then, okay? So, standard form means 2 things. Okay? It means that we have it alphabetical. We're going to have it in alphabetical. Sometimes you have multiple variables.
I didn't know how to spell that.
Okay? Alpha, betical.
I've never spelled that in my life, I don't think.
Okay, well, hey, it's up there now. Okay, so it's alphabetical. So write that in. And then also, we need it to be in descending order.
Yep, you lost me.
Yep. I'll gain you back. Don't worry. Just write it down for now. Just write it down. Trust the process. Joel MB, trust the process.
I don't know, I feel like it'd be easy to just do that. For real. It could be.
I mean, I don't want you to, for what it's worth.
Did you write that thing right there behind you?
No, my TA did. But I think they're important nonetheless.
Yeah, me too.
Oh, something got erased of it here when I leaned against it.
I was tired.
No, every time it was tried.
Yeah.
Oh, it kind of looks like it. All right. Alphabetical means it's going to go in order of the alphabet, right? So, would X come before A?
No.
No, A is going to come before X, okay? And which one would come first? M as in meme or N as in nighttime? M as in meme, right? Okay. Now, descending, what does it mean to ascend?
Go up.
Go up. What does it mean to descend?
down.
Go down, okay? So we're going to go in descending order. So we're going to start at our highest exponent and go down.
Oh.
So it's descending in terms of exponents, okay? So alphabetical in terms of variables, descending in terms of exponents. So of these, 18x squared minus 21x to the third plus 30, are there any issues alphabetically here? No, okay. So they're all x's. But which one of these is going to come first?
21.
The negative 21x to the third. So I'm going to put one underline underneath that, okay? So I really encourage you guys to put one underline underneath that because it's coming first. Okay? What's going to come second? 18x squared. I'm going to put 2 underlines underneath that. Do you guys see the pattern here?
Yes.
Okay. What am I going to put under 30? 3 underlines, okay? So I'm going to put negative 21x to the third plus 18x squared. Now, why is it a plus 18x squared? Because it's positive, and that negative had to go with the 21, right? And then what am I going to put at the end?
Plus 30.
Plus 30. Very good.
That's all?
Yep, that's all. I put that in what I call standard form. Okay, we want to be very careful with standard form. This is just a universal way so everyone has it in kind of the same order. So that way when you look at a polynomial, whether that's in here or in a higher level math class, or even in a business model, like in a spreadsheet, for example, okay, everyone knows what you're talking about and it's in the same order. It's universal. That make sense?
Yeah.
All right. On number 2, what's going to come first? Whoa. I heard two different things.
Negative x.
No.
10.
It's negative.
Negative 3.
Wait, negative 3 because negative x is just 1. Negative 1.
Okay, this has an exponent of 1 on it. But wait, is there a tie for the biggest exponent?
Yeah.
Yeah, so they're both going to get 1 underlined.
Oh,
10x squared and negative 3x squared are both going to get 1 underlined. There's a tie, so they're both going to get 1 underlined. Okay, what am I going to put under 9x? 2 underlines. What am I going to put under negative x? 2 as well, because there's another tie. So here's what I'm going to do.
Adam.
Can I combine like terms here?
Yeah.
Yeah. And now what's underlined is like terms. 10x squared minus 3x squared is what?
7x squared.
7x squared. And that's coming first because I have 1 underline underneath each. And then what's going to come next? What am I going to put next?
Plus negative, or plus 8.
Plus 8x. Very good. Went ahead and added the 9 and the negative 1, or subtracted 9 and 1, however you want to look at that.
Wouldn't it be then 2?
Great question. It would not change the exponent. So last test, okay, earlier in the chapter, okay, we had when we multiplied with the same base, we changed the exponents. Are we multiplying the 9 and the negative 1 though? No. So when we're adding, because we have to be concerned, because we have to be careful of having the same exponents to start, we're not going to change the exponents during the process, okay? We're only going to change the exponents when we multiply and divide them. Yeah, good luck. Does that make more sense?
Yeah.
Okay. All right. Let's look at number 3. What do we think is coming first on number 3 here?
Negative 8 to the third.
Negative 8 to the third. I would agree. Okay, what do we think is coming second? Ooh, 7a squared and 3a squared. Maddie made sure to get that and in there, okay? Because there's a tie. What next? 2a. But wait, is the 17 and 2a?
No.
Just 2a. Because does 17 even have an a?
No.
No, so it's coming with 4 underlines. So now that we have everything kind of underlined, is it a little bit easier just to visualize what comes next?
Yes.
Okay, so we go through the process. For my first thing, I'm going to go through how many things have 1 underline?
1.
Just 1. So I don't have to worry about combining anything. Negative 8 to the third. Now I'm on my second thing. How many things have 2 underlines? 2. So I have to combine them. 7 plus 3. 10a to the second. Once again, we don't change those exponents, okay? How many things have 3 underlines? Just 1. So I'm just writing plus 2a. Very good. And then what am I writing at the end?
Plus 17.
Plus 17. So notice how everything just keeps going down in power. I don't know about you guys, but to me it just looks more organized now than it did before. So negative a to the third plus 10a squared plus 2a plus 17. Now I want to talk about what would happen in a different scenario. You don't have to write this down. Okay? I want to talk about this though. So let's say we were to have, I don't know, 6b squared plus 5a minus 4x to the third. Okay, what would come first here?
The negative 4x. 5a. Oh.
Why would 5a come first, Reagan?
Oh, alphabet.
Alphabetical. A comes with 4x. So we'd have the 5a first. Then what would come next? 6b squared. And then the negative 4x to the third, right? Even regardless of the powers, because alphabetically. Now when there's the tie, we go on to the next thing, okay? Now what would happen though? Another scenario. Once again, you don't have to write this down, okay? Let's say we have this other scenario. I'm just going to block it off my space here, okay? Where I don't know, we were to have 3ab minus 4a squared plus 2a plus 5b squared. There's a lot going on there. Okay, well, what do we think would come first?
I think 4a squared. 4a, 2a.
Wait, no.
I think 4a
It's positive
squared.
2a.
Okay, so we have to say alphabetical. So we can rule out 5b squared, right?
Yeah.
But how many of these have an a? All three of these do.
Yeah.
So then we say, okay, once we're in the a's, which of these three would come first as far as descending order?
5b.
Negative 4a squared would come first because it has the highest power of a.
Oh.
Now, do these both have the same power of a? They're both a to the first. So how do you decide which one comes first? Do you just do a coin flip?
The higher number. 2a.
We're actually just going to give the tiebreaker to the one with the second variable. We're going to give the tiebreaker to the one with the second variable. Then we're going to have the one without the second variable go next. Okay? But they both have a to the first, a to the first. And then last but not least is going to come the one without any a's. So negative 4a squared plus 3ab plus 2a plus 5b squared would be what we have here for our descending order. Okay? Do those two make sense or no?
Yeah.
Okay.